Okay, hello everybody. Let's continue solving some of those Leetcode questions. I was hearing a lot of people say they wanted to solve, they want to see this one solved. Of course it's a joke, I'm just alone in the room, but I am guessing you guys wouldn't mind me solving this one, I guess. So, let's see, there was something about a matrix. So 1351. Count negative numbers in a sorted matrix. Okay. Given a m by n matrix grid, which is sorted in non-increasing order, so in decreasing order, both row-wise and column-wise, return the number of negative numbers in grid. Why do I care about it being sorted? I don't know. I mean, they don't really want me to sort it or something like that. I guess you could save on runtime if you are going for performance, since as we can see the grid, we can basically start from right to left in each row. So you can imagine. Okay, let's paint it. I'm assuming for this example, we would have, for example, the first row would be 4, 3, 2, -1. The second one would be the 3, 2, 1, -1. The third one would be 1, 1, -1, -2, and -1, -1, -2, -3. And yeah, you could actually, shouldn't write those separated. Anyway, like you could spare yourself the comma. So I'm assuming going, I don't know, how does the, okay, we'll see, we'll look at the constraints a bit later, but let's quickly think about this. If we are looking only for the negative numbers, we can go for each row, we can go basically right to left, right? And if we have any negative numbers, they would be standing on the far most right side of this row. And then if we find one, we can go to the next one, to the next one, until we find a number that is no longer negative, and then we can basically halt and then go to the next row. So this saves us a chunk of numbers that we don't really have to cover. For example, here there are like 3 of them, here there's like 2 more. In this case there's, I meant 3 more. The next one there's 2 more. And in the last one there are like no negative numbers. So, oh, they're also sorted column-wise, right? That's what they meant. So you can basically approach it on a per column basis, or you can approach it on a per row basis. I could see an optimization here as well. For example, this is a perfectly square matrix, right? This is a square matrix, but you can imagine a matrix having like one element here, 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 and then here, 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 here. And this is a 2x4 matrix, right? So if you go with looking at each row, assuming they are really sorted both row-wise and column-wise, you could cancel out more elements if you find the first positive number very soon, by looking at the rows by comparison to looking at the columns. So you could basically save some more runtime like this as well. But I don't think this is there is no requirement here. It's just something that maybe a interviewer might ask you about. I know interviewers at Google and those companies like the FAANG companies would basically always kind of ask you about runtime complexity, space-time complexity, possible optimization, further optimizations. So this is something that it's always good to kind of keep in mind. I think that's why they kind of give you this extra information, extra format. In this case, there will be 1, 2, 4, and another 4, so 8 negative numbers in the matrix. In this one there are 0, in this one there are 3, in this one there is only 1. And as you can see, the matrix could be a, okay, this is a 1 by 1, this is a 2 by 2. Let's see the constraints. Our M, which would be, I think, the number of rows, would be grid length. Let's see how this is given. Okay, this is given in a very simple, like the most basic Python format. Usually nowadays I work with NumPy if I want to work with my matrices, or maybe even just pandas. But I guess that's now a good opportunity to kind of cover working with very basic data structures when it comes to Python, right? So M would be equal to the grid length, and N would be for each of grids, so basically for each column of the grid, because you can see oh no, let's see, I guess N would be because this would be each eye of this grid, so I'm assuming they kind of see those as columns and not as rows, assuming that N is always given as a number of columns. Doesn't really matter, it's just a way of thinking about this. So basically this assumption should be kind of flipped. So basically this would be a whole column, like this would actually be positioned like here, this would be positioned so, this so, and this so. Anyway, doesn't really matter, just a thinking discrepancy. Our M and N are both a number between 1 and 100, and they don't say the digits inside of each index or each cell in the matrix are between -100 and +100. So we wouldn't really have any problems with the digit overflow, like number overflows and stuff like that. But we can see that M and N are definitely not constrained to be the same size, and they were kind of careful not to give us any of those examples. So you should always kind of cover, you should think about those type of problems when it comes to their basic data structures, and in this case this is stuff from linear algebra. So if you haven't covered any linear algebra, maybe get some basic information on the most basic stuff about matrices. They would definitely talk about dimensions and some properties, and maybe just it would help you to kind of get some of that information into your head, so you remind yourself, hopefully at some point, that you should take a note and pay attention to all those different dimension combinations as well. But anyway, this is all for optimization purposes. Now in our case, we wouldn't really care about that. We only want to count the negative numbers, so we will still do the reverse counting just because I think it's cool. So let's see. Let's name them the way I would like to name them. I would say for a row in grid, and I would actually do this here firstly. Let's see our input. Right, grid would be this. Whoops, would be this, and let's say for a row in grid, print row. And I'm just doing this to kind of see how the program would actually be seeing these things. The way it's seeing them is exactly how I imagined. So this would be the row. And now let's see, we are already looking at each row, right? So why not have a counter, should be 0, for cell in row. So basically we are already on a row level. So now let's look at each cell, and we should definitely start looking at was it like that? I think it was something like that. So this would basically, this is the advanced slicing operations and stuff like that. I'm not sure exactly the name. I think it was something that was part of slicing. So this should reverse the order. Do I want to do it this way though? Let's put this. I think that's why it's complaining. Exactly. Let's actually, let's first quickly just print it and see that this is my assumption. Otherwise you would have to Google, but like I said, I kind of do this stuff frequently, so I'm kind of assuming. So yeah, let's have it first like this, secondly the other way around, and yeah, we had it here like this, then we have it like this. So can we get a answer by having a single pass? Let's think about this a bit later, and I will kind of show you what I meant by that. So let's just get each cell and manually see if cell well, let's equal than 0, and we will update counter, else. So this is our kind of like sub-optimization. Else we would basically say was it continue, and I want to quickly, well, no, this should definitely, we should definitely break, right? Let's just quickly Google it. I am always kind of confused still by this terminology. I don't know why. Whenever you're not totally sure, it's best to actually Google stuff and not expect to just wing it, because there are plenty of bugs that happen due to unforeseen logic and just order of operations anyway. So you don't really you shouldn't really try and basically put more bugs just because you didn't want to Google something for a second. So let's see, what would a break mean? Exit loop. What would a continue mean? Let's see. So again, break for varying sequence, if condition, break. Code inside. So yeah, this would definitely break the loop. What about continue? Well, the continue would basically go to the next iteration in the loop. So are we going to the next iteration? Well, no, because we don't want to see it. We don't want to look at the next cell. We actually want to break from this loop and go to the next row, right? Because we already are either looking at the negative values or it's not a negative value. So we basically want to skip the whole thing. So we basically want to break this loop and go to the next row loop, right? So we break this loop, go to the next row loop. And in the end, our algorithm is already doing the whole thing, right? So it goes through each row, it will look at each cell in backwards order, and I think this is just indexing. It wouldn't really sort. So runtime wise, it would still be optimal, and it would look at the cell value, and if it's a negative value, it would update our counter. If not, it will skip that row and it would go to the next one. Even just executing this one, I think, let's see, let's print the counter real quick. And yeah, counter is 8, and we know from this example that the counter was supposed to be 8. So let's get our our solution. We can just paste it, and yeah, let's indent things properly. So we have a grid. I'm not sure why it doesn't like. What did I do that it doesn't now like? It's red, whereby it doesn't really have to be something. I pasted wrong. Well, I don't think I pasted anything wrong. I think it's just some styling issue. Doesn't really matter. Return counter. Let's see if our counter is actually updated properly, and maybe we can then think about some further optimization. For example, do we really need to update a counter? And do we even need so much looping? Can we make this, or maybe before even thinking about some more Pythonic ways, can we just first think about some other edge cases? For example, if we have an empty, basically an empty grid, should give us a 0. Oh yeah, well then we'll just get this one, a1. This is the minimum. Yeah, this is the constraint that I didn't pay attention to. Okay, what else do we need? So yes, this would be at the 0, and it was the expected one. At this point you can really just leave the code like this, right? I would usually just think about some Pythonic way. For example, a double for list comprehension that would give me some Boolean array, for example. Is this a good idea at all? For example, if something like pandas, I would basically write a mask that would get the whole thing on a Boolean basis. It don't really need to loop between things. You could definitely have, but it wouldn't break. And the break, I mean, there's the thing about this algorithm right now. It looks a bit standard, non-Pythonic, but at least there's some possible optimizations happening here. So I would just leave it like that. Let's try and submit, or maybe just quickly think about what we did. Firstly, we basically handled looking at each row and getting the negative values. We also we didn't really do any optimization based on these dimension differences, but I don't think that's something that's super interesting right now. But we still thought about it, and it should still be covered by our current implementation. What else? Our algorithm can scale up to those dimensions without an issue. It's actually optimized, so for such big cases we should be actually faster, and maybe it will reflect on when after we submit we can see how our code compares runtime wise. And yeah, the values are not an issue, and yeah, I think this is actually ready to submit. So let's see what we'll get. Wrong answer, hey? So are they counting? Oh, did I really? So I actually by mistake also counted the 0 as a negative number. that's the thing, right? When you're programming on your own and you're in your head, basically you can definitely just focus on just the logic. And this is the first thing that will like be the problem with that type of work when it comes to interviews, is that during interviews you will have to talk with the person that is actually sitting next to you and looking over your shoulder, basically, right? So me just trying to talk and basically say my thinking out loud got me into forgetting or just not paying attention and just leaving the zero as part of the negative numbers. So it's a good thing for me personally and for everybody who's trying to get to practice for such interviews. Try to kind of try to write down your answers on whiteboard and stuff like that. Try to speak your answers out loud, so you actually are as close as possible to the real experience you would get during an interview. So let's see, my runtime was actually not that fast. Probably some people did some stuff better. I'm assuming something with this counter math was not up to snuff, and maybe the optimization for the rows and columns. Maybe we can do that. Why not? How can we get the dimensions? If we have a grid print grid len grid, I'm not sure. I don't think this will even work like this. Oh, it definitely did, right? Grid 0. Let's shorten it up so we actually know what we're looking at. Zero, no. How would you work? Now that's me not completely understanding how to work with primitive data structures when it comes to Python, right? So it's a list within a list. So if I just get, okay, basically this is the length of the row itself, and if I just get the length of the outer list, which contains each row, I should get 2. Yes. This is a bit weird. It's not super cool. It's not very readable, but let's get this optimization going. How can we get the optimization like that? Well, I don't think I can. I'll still be looping through each row. What you can always do is pack this list into a data structure that is more optimized for this type of operations, for example, in NumPy structure. But I think I'll leave this for now because we're gonna take just as much time just rewriting the whole code to work with more interesting and more flexible data structures. But yeah, I think it was still a good type of question. You got to see and kind of have to work with some matrix operations. You kind of have to think about stuff on a matrix level, and also in reverse order sometimes, and sometimes you have to cancel loops. So yeah, I hope that was also educational for you guys, and let's see you next time. And I'm thinking that maybe I'll not upload every 2 days, maybe even like every other day. It would kind of depend on how much time I have for this type of stuff. But yeah, don't be surprised that sometimes there will be new videos every day, and sometimes there will be videos every other day and stuff like that. So yeah, have a good day and see you next time.